Number 7 is a non-calculator problem, I believe. Am I right? So position along the x-axis is given by e to the negative t times sine of t, and it gives you an interval from 0 to 2 pi. Closed interval. It says find the time at which the particle is furthest to the left. What is that looking for? If the particle is moving along the x-axis, how do we know if it's furthest to the left? What'd you say? Not negative, no. Think of this in terms of derivatives and functions. How do I know if the position is furthest to the left? What would the graph look like? The graph, remember, is doing this that represents the distance along that. Maybe.
Because when we talk about part position, are we talking about like the number line moving to the left and moving to the right of it?
We're talking about a particle moving back and forth on a number line. The function that represents that is going to look like this. So the function that represents that might look like this, where this is x of t and this is t. So hold on. If I say this is 5 and this is 4, and that's obviously 0, and this is let's say negative 2 or whatever. What is the position when t equals 0? 4. What does that mean? It is 4 units to the right of the origin. What is the place, or when is it furthest to the right? So let me put some points in here. Let's call this A, B, C, and D. When is the position of the particle furthest to the right? At A, right? When is it furthest to the left? When t equals c. So what am I asking for when I'm asking for the furthest to the left? The absolute minimum. You guys following that? So that's all we're looking for is the absolute minimum. So what do I do to find an absolute minimum? Well, the derivative depends what's given. What's given here? Position. So how do I find an absolute minimum? I'm looking at the velocity, okay? Taking a test? Okay. So velocity, let me write this down. X of t equals e to the negative t times sine of t. So what is velocity? What's that again? What rule are we going to use? Product and chain. So what's the derivative of the first thing? Negative e to the negative t, right? Because the derivative of e to the anything is the same thing, but then times the derivative of negative t. So negative 1 times sine of t plus cosine of t times e to the negative t. So let me rewrite this just so it's a little bit simpler to deal with. The first isn't going to change much. But the second one will be plus e to the negative t times cosine of t. So that's velocity. What am I looking for on velocity in order to know when the position is furthest to the left? We're looking for the absolute minimum of position. So when does a minimum occur? When the original function goes from decreasing to increasing, but we're not looking at the original function, we're looking at velocity, we're looking at f prime, right? So we're looking for when this changes from negative to positive. But how do I know when it changes from negative to positive? Find all the critical points. So what's one type of critical point? When velocity does not exist. Can I plug in any t value? So velocity, and plus we're looking at the domain 0 to 2 pi. So between 0 and 2 pi I can plug in any value. What's the second types of critical points? When velocity is 0, so we'll set this equal to 0. The question though is, how do we solve this? So factor. So we'll factor out e to the negative t, and we're left with negative sine of t plus cosine of t. Interesting. So we can do the zero product property. The first term has to be 0. Does that ever equal 0? No. Or this equals 0. So we would say 0 equals negative sine of t plus cosine of t. How am I going to solve that? Unit circle, yeah, trig, yeah, okay. How about we add sine to both sides? What do we get? Sine of t equals cosine of t. You could think of it that way. When does sine of t equal cosine of t? Or you can divide by cosine. So you'll end up with sine of t over cosine of t equals what? No, equals 1. And then sine of t over cosine of t is tangent of t. So you can look at either when is sine equal to cosine, or you can look at it in terms of when is sine equal to 1. Or sorry, when is tangent equal to 1. So when is tangent equal to 1? When is the opposite and the adjacent the same? So when t equals pi over 4. Is there any other place? Okay, 5 pi over 4? Because then they're both negative? Is there any other ones? Maybe 7 pi over 4? Right? But yeah, looking at the domain, it's only from 0 to 2 pi, right? So those are critical points when velocity is 0. What are other types of critical points? At endpoints. We already determined the derivative will always exist in this domain. This is when the derivative is 0, and then we're looking at endpoints because it's a closed interval. So we're going to say the critical points are when t equals pi over 4, 5 pi over 4, 0, and 2 pi. Are you guys okay with that? Yeah? Those are the only places where you can have an absolute min, only place where you can have an absolute max. We could do a number line right now. Let's do a number line, just see. 0 and 2 pi. And we get what, pi over 4? Somewhere in there. And 5 pi over 4. So this is when velocity is 0. And these are endpoints. So what's a good number to pick, maybe? Pi over 6. Pi over 6. So this is always positive. Maybe I should use the factored form here. That's always positive. What's the sine of pi over 6? Let me do this real fast. Actually, you know what? I'm gonna avoid this. There's a reason. If let's just say this is a positive and negative and a positive, right? That's not the case. I don't know. But what would that make 0? A max or a min? A minimum. What would that make pi over 4? A max, a min, and a max, right? The question is, when is it furthest to the left? In other words, we're looking for the absolute minimum. So then we would be considering that value and that value. But we know that the minimum occurs at one of these no matter what the signs are. So what I would rather do is let's just evaluate all the critical points. It would actually make it easier. It'd be quicker. If we do that, then we're going to find the absolute max also, even though it's not asking for that. So what am I going to plug these values into? The position, because I want to know when it's furthest from the left. So you could do a table if you want, but I'm just going to do this. X of 0 equals what? Is it 0? E to the negative 0 times sine of 0, which is sine of 0 is 0, so that's 0, okay. X of what? Pi over 4 is the next one. So that's e to the negative pi over 4 times sine of pi over 4. What's sine of pi over 4? Rad 2 over 2? Do you know that one? No. So I'm just going to leave this as rad 2 over 2 times e to the negative pi over 4. Gross. What's x of 5 pi over 4? e to the negative 5 pi over 4 times sine of 5 pi over 4. What's sine of pi over 4? 5 pi over 4? That's going to be negative rad 2 over 2, isn't it? Be down. Times e to the negative pi over 4. And the last one, x of 2 pi. Oh, thank you. Negative 5 pi over 4. And then e to the negative 2 pi times sine of 2 pi. What's sine of 2 pi? 0? Oh, that's nice. So find the time at which the particle is farthest to the left. So we are looking for the absolute minimum. Which one's the least value? At 5 pi over 4. Because these are zeros, this value is what? Positive, and this is, since it's only negative 1 out of all those, that's it. So notice it doesn't say what is the first, where is it? It says at what time value. So we'd say, therefore, when t equals 5 pi over 4. That's it. Yes?
I don't understand why it's to the left, like farther to the left. I know you explained it earlier, but I don't understand.
We're not talking about on the xy axis of this function.
Yeah.
We're talking about this little particle moving this way, and then moving this way, and then moving this way, and then moving that way, and so on, okay?
The word left is
Left usually implies what on a number line?
smaller.
Smaller. So furthest from the left would be the absolute minimum. Yeah, basically, when we're looking at this graph, x of t, we're taking the position and kind of flipping it like this, so that when it moves left, it's moving down on the graph. When it moves right, it's moving up on the graph. Because this axis is not position, it's time. Does that make sense?
Yeah.
Okay. Are we good with this? Any questions on this?
Is the justification just the word?
Yeah, this is actually your justification. Okay. Okay. That's that. So as far as, there's a lot of points there. There's 5 points. You're going to get 1 point probably for getting v of t, the function. You're going to get 1 point for setting v of t equal to 0. You're going to get 1 point for identifying all your critical points. You're going to get 1 point for evaluating all your critical points, and then 1 point for the final answer. You guys okay with that? Okay. Part B. This one's a fun one. Can I get rid of this? I am. All right, part B. All right. Oh, I shouldn't have erased that. Oh, well. I needed something off that. So part B says find the value of the constant a for which x of t satisfies a x double prime of t plus x prime of t plus x of t equals 0.
Ew.
Yeah, that looks gross, but it's not that bad. A is a constant, right? Okay. X double prime is what? Acceleration, you just got to take the second derivative, right? And then x prime is the derivative. And so you just got to plug in your second derivative, the first derivative, and the function into that equation and solve for a. So, x of t is this, so let's figure out what x prime is. I just did that, but I don't know why I got rid of it. So it would be negative e to the negative t times sine of t plus e to the negative t cosine of t. Right? So we got to find the second derivative now. So what's the derivative of that? That's just going to be e to the negative t times sine of t plus cosine of t times negative e to the negative t. Yeah? Plus, what's the derivative of that now? Another product rule. So I'm going to put negative e to the negative t times cosine of t. What's the derivative of cosine? So minus sine of t times e to the negative t. Okay. I'm going to simplify that just a little bit. So x double prime of t. This is gross. Is there anything I can combine here? Right here, if I put e to the negative t in the front, that becomes negative e to the negative t sine t. And then I have a positive e to the negative t sine t. So that goes away. And then,
Those two add up.
yeah, because this is a negative out front, right? And that's a negative, so we'd actually get negative 2e to the negative t cosine of t. So that's nice. All right. Now what do I do? Yeah, plug it into that thing. It says a times x double prime. So it'll be a times negative 2e to the negative t cosine of t plus x prime. So plus that. So it's just going to be what? Minus e to the negative t times sine of t plus e to the negative t times cosine of t. And then plus x of t. So plus e to the negative t sine of t equals 0. So now we just need to solve for a.
Those two cancel out.
Yeah, you got negative e to the negative t sine t and e to the negative t sine t, so that goes away. Now, let me rewrite it. I'm going to say negative 2a e to the negative t times cosine of t plus e to the negative t times cosine of t equals 0. You okay with that?
Okay. Now what?
What could I do now?
Factor out cosine.
Let's factor out e to the negative t times cosine of t times, what's left over? Plus 1. Am I right? Equals 0?
Yeah. So then a
So when is this equal to 0?
when
Or never.
It,
Never.
yes, because if cosine
yeah, because then cosine could be 0. But that doesn't matter because I'm trying to solve for a. So really this, I could divide all that. Doesn't matter when this is 0. So we could just say when negative 2a plus 1 equals 0. So negative 2a equals negative 1. So a equals 1/2. Oh my goodness. That's it. So the purpose of this problem is just, can you take a derivative correctly? Using product rule, using exponential rule, trig rule, all that stuff. Okay? Are we okay with that? I think you're probably going to get a point for x double prime. You're going to get a point for setting that equation up maybe. And then a point for getting it down to that, and then a point for that.